Okay, I'm redoing this video for the third time now. I'm kind of getting a little agitated about it. But right here is a vintage 1934 General Electric AC motor. This came out of a Walmart window fan. Obviously not the original motor, but it wasn't. Here's the bracket, and it wasn't mounted correctly into the fan, so I took it out. I have another Walmart fan, which I do want to make a video with the original motor, except it was painted yellow, but it looks really nice, and I ain't gonna complain. But that's got the original Craftsman motor. This is a replacement motor. Obviously, this is way older than the Walmart fans are. Got it for free. Works fine. It's a General Electric, or GE, 5KS A47C3, that's the model, type KSA, frame 47, form 0, 110 volts, 5.4 amps, one phase, or single phase, quarter horsepower, 60 cycles, 1725 RPMs, 40 degrees Celsius, temporized, continuous operation, patent 1566939, and you see 634. That I assume is the date. It's a very big, heavy motor. Half-inch shaft on this thing. Repulsion start. Obviously, somebody did something with that, but that's okay. That's Bakelite. This cover. It's the brush cover. There's two fairly large round brushes in it. Rear bushing, oil port. You see the GE logo on the back. They have not done anything to it but put a new cord on it. Oil port on the front, cooling vents. This wire came off an air conditioner or a dehumidifier or something, and I just literally pulled the ground pin out right now because one, it's not grounded anyway inside, and two, I didn't feel like getting an adapter or finding an extension cord, unwrapping a 50-foot extension cord, or going out to the garage to get a smaller, shorter grounded extension cord. So I want to just rip the ground pin off. I don't recommend doing that, but whatever. That's a Bakelite cover. I have to clean it up a little bit, or actually a lot. Inside there you can see is the windings. The rotor, or the armature, is actually what turns the brushed motor. And this outside piece right here, this ring on the outside, that's actually the squirrel cage. And the winding spin. It's literally an exact opposite of a standard induction motor. It's a repulsion start, so it does have a starter switch in it, centrifugal switch, and when you turn the motor on, it starts up. You can hear the windings harmonize a bit, and then you hear a click, and it disengages when you turn it off. Obviously, as it slows down, you'll hear a click, and that's the centrifugal switch closing again, so it's ready to start again. I'm going to start it. This might be really bad. It might jerk around. It depends. Depends on how good this is going to go. There we go. Runs very smooth. I have not done anything but put a new cord on it. I have not even lubricated this motor. That squeaky, clicky sound was the switch. This thing really kicks quite a bit. There we go, ready. Runs well. This motor is pretty heavy motor, obviously. Obviously, it does take this motor quite a while to warm up, but once it does warm up, it'll stay warm for hours. Looking at the bottom here, I can show you the inside. Got an intake air vent there. You got another intake vent here. Well, a little bit of air does come out, not much. And then this back vent here is an exhaust vent, and that's where all hot air comes out of. And this motor does get very hot. And it gets hot enough to the point where if you put your hands on the exhaust vent, it actually does hurt. You can see the squirrel cage design on the outside of the stator. You can see the armature windings, and they do spin. Back here, I don't know if it's reversible. I would imagine it might. I don't know. It doesn't say it is. It might be electrically reversible by moving a switch. Oh, there's more writing down here. Never noticed that. 051-15, and then just letter D. This is where the bracket bolts onto. I gotta clean up the bracket. If we look in there, you can see that disc back there is the commutator. And I'm trying to get a good view. Oh well, the centrifugal switch is somewhere in there. Right there. I think that's it. I don't know. Somewhere on the back there is the centrifugal switch. That might be it. I don't know. I gotta look. I have not really looked inside this motor a whole lot. That's part of it. Yeah, so basically what the centrifugal switch is when the motor starts, and the other Homart fan has a motor. It is a brushless motor, but it does have a centrifugal switch. Well, it's probably brushless, but it might have brushes in it for the start windings. When you start it, right now, when I turn it on, the switch is closed, making contact. And when power is applied at first, the start windings are energized. That allows the motor to have torque and get up to speed. That's why the lights just dim, because it takes a lot more electricity with the start windings and the run windings running. You can see. When I do that, when the start windings are engaged, it kicks a lot more than when I just turn on now. Maybe not. But the light doesn't flicker nearly as much. But right now, I'll show you. Right now, when I turn it on, the start windings are going to be engaged. And those windings produce a strong enough magnetic field to get the motor started from a dead stop with high torque. Now, those can't stay energized for very long, otherwise they will overheat and burn out. So what happened was once it started, that clicked, the switch opened up, those windings are no longer energized, now it's just running. And it'll run happily, just as it is. I ran this thing for about an hour and a half. Just like this. It had a pulley on it. And I just had it running, and it got pretty warm, but once it got to a certain temperature, it never got any warmer, obviously. Continuous operation motor, and it is air-cooled and self-cooled. It's not going to overheat. And it does run really nice. And this is definitely one of those things that is going to be a bit of a project. And then right now, when I turn it off, you'll hear it when it slows down. You'll hear a squeaky click. There it was. And that was the centrifugal switch closing, and now the start windings will be energized when I put power back on, when power is applied to the motor again. And that's how it works. Can't stay, those windings can't run long, but they produce enough torque that the motor is able to start and get up to speed even under load. Thanks for watching. Your heart lays where the rebel